Hello, and welcome to another video tutorial for the Flame Tracker application. In this video, we will go over the color tracking method described in the wiki page Color Tracking. Let's say that we have a video of a spreading flame, like the example video in the repository, and we want to measure flame position, flame length, and spread rate variations. We saw how we can edit the video, how to use the manual tracking to click on the flame location at different times, and the more automatic Luma tracking method. There are some cases where it is more useful to track a flame region having specific colors, and the color tracking method offers the possibility to do that after setting some initial parameters and then processing the video. I'll start by running the flame tracker, and then I will open the example video. When I'm done, I can load the parameters from the CSV file in the same folder. As we saw in the previous videos, we need to correct the perspective of the video, and to do that I select the first frame where I can see the entire sample. From the preview, I can see that the region of interest doesn't include the entire sample, so I need to select a new and larger region. If I click on the correction now, I see the four corners and I can click on them. If you need more information about the perspective correction, you can check the video editing section of the wiki pages. Now I can change the first frame back to 1000, and then I select color tracking from choose analysis. The analysis box gets populated. For example, we have the flame direction, that in this case is right to left, and some parameters we can play with. If I scroll through the video now, in the analysis box I see two images. The one on the left showing the pixels of the region of interest filtered in each RGB channel, as we will see in a second. And on the right, I see the corresponding binary image where the white pixels indicate the flame. The three RGB channels of the frames can be isolated and controlled separately. The intensity of each channel goes from 0 to 255, since in most cases we will use 8-bit images. I can select the minimum and maximum values of the intensity in each channels, and I can use these thresholds to isolate the flame region from the background. In general, I'll start from the red channel, as I expect it to be the dominant one for flame videos, but of course this depends on the camera setting and the detector used. If I move the minimum and maximum values of a channel, I can see how the changes affect the flame region. Depending on your application, you might want to isolate the yellow region of a flame, for example, which is characterized by soot production, or the entire flame in other situations. If I want to check the filtered images a little bit better, I can click on Show Frames, and the two new windows will open with the frames. When I'm done, I can press the Escape key to close these windows. There are different opinions on what the flame region actually is and how to define it, so the final choice of the filtering is not unique. It can happen that when you select a channel range, you still have small regions that are not part of the flame. In this case, you can filter the small particles out by using the slider of the particle size. Keep in mind that the maximum value of the slider corresponds to 25% of the total area of the region of interest. So if I change this region, the maximum will change with it. Once I find the set of values that work for me, it is always good to check other frames with the preview slider to make sure that the tracking is consistent. The edge lines shown in the two images can be shown or not based on the checkbox in the bottom right. The edges are calculated as the maximum and minimum locations of the flame region, but sometimes it is more appropriate to average these locations with more than just one pixel, and we can do that by changing the number of pixels in the relative box. The color tracking can look for connected pixels in two ways, 4 and 8. The difference affects the flame contour, but usually it doesn't have a strong effect. Once I am satisfied with a typical frame, I can check other frames with the preview slider. If the region of interest is large, there might be a little delay with the preview, and actually it is always good to reduce the region of interest to a minimum to increase the speed of the video processing, since there will be less pixels to be considered. Before the tracking, I can save the filtering values in the left column of the analysis box in a CSV file by clicking on Save Filter Values. If there is a flashing light in the video, for example to show the fuel surface behind the flame every second or so, I could select the flashing light box, and the automatic tracking will skip all the frames where the luminous region is larger than half of the region of interest. This function is optional and we don't need it for this video. Now I'm ready for the analysis, but to speed up the process I will skip 14 frames. Since the frame rate is 30, this means that I will consider 30 divided by 1 frame considered plus 14 skipped, so for a total of 15. So I basically analyze 2 frames per second. Remember that you can check the help button on the right of the preview box to check this calculation. All I need to do now is to click on Start Tracking, and during the processing the user interface will not be responsive, so until the process ends it will not be possible to interact with it. However, I can check the progress of the tracking from the terminal window. At the end of the tracking, the 2 graphs in the analysis box show the variation of the edges position versus time on the left and spread rate versus time on the right graph. The difference of the edges position is basically the flame length in this case. You can interact with these graphs, for example by dragging them with your mouse or zooming in and out, and if I click on this symbol at the bottom left, I go back to the original. You can also right-click on them and select log-log plots, for example, or directly exporting them. The data looks a little noisy, and it's not clear if some flame changes are happening or it's a processing issue. I can smooth the data by using a moving average, and I can select the number of points to consider in the relative box. Note that this number is not the total number of points used for the average, but the number of points to consider before and after a single frame. For example, until now we've been using 2, so we've been considering a given frame, 2 frames before and 2 after, for a total number of 5. If we type in 5 and track the flame again, we have a moving average calculated with 11 points. Since I'm analyzing 2 frames per second, this means I'm averaging the spread rate over about 5 seconds. Appropriate values for the moving average depend on your specific needs, and they could change with the speed of the flame and the frame rate considered, for example. At the end of the tracking, I can see that the spread rate values are much closer to an average value slightly over 1 millimeter per second. There are 2 main oscillations of spread rate close to 80 and 100 seconds, and this means that something might have happened there. I can go back to the preview and check, but remember that whenever I do that, I will lose the tracking data currently in the analysis box. From the preview, I can see how the flame has a little burst that pushes the flame front ahead. This is a natural flame mechanism and not a processing issue. So at this point, we can decide to keep it or rerun the analysis, for example, by considering a smaller portion of the flame. What I mean by that is that I can select a new region of interest only for the upper side of the flame and track it again. Remember that if I change the region of interest, the filtering of small particles might need to be updated first, and it's always good to check the preview before the analysis. This time, before I click on Start Tracking, I can select the box for the video output. This option will create an output video of all the frames considered, and if the edges box is selected, we can use it to check the tracking accuracy. The program uses the codec and format information from the preview box to create the video, but for this function you don't have to worry about the frame rate because the program automatically calculates it. Now I can track the flame again. At the end of the tracking, I can see that the spread rate variation is much smoother. Of course, the decision of what data is more relevant depends on your application. Now I can check the output video to visualize how accurate the tracking was, and the output video is in the same folder of the original video, and it's named as tracked video at the end. I can open it and check the edge's position. If I am done with the analysis, I can save the data from the tracking as a CSV file by clicking on Save Data. The measured edges location, spread rate, flame length, and area are saved in this file, as well as some information of the video. If I want the edges location in absolute terms, I can click on Absolute Values, and the downstream edge, the right one in this case, will start from 0. Note that once you click on Absolute Values, you cannot retrieve the previous ones, so you might want to save the original data first. This concludes the tutorial of the color tracking method, but remember that you can always use the Help button to get more information about the analysis box. Thanks for watching and good luck with your analysis.